Okay, so what we want to look at then are signed areas. So we've done a bit of work on finding definite integrals and calculating those and solving similar sort of problems. But looking specifically at areas under curves. So this is just straight in your textbook, so you can kind of follow along as we go through it. We'll just make it nice and easy. When we're calculating the areas between the graph of a function and the x-axis, using that definite integral that we've seen, okay, from a to b of f of x dx, the area is signed, which means your area that you calculate will either be positive or negative, depending on whether the function is above or below the x-axis. Okay? When the region is above the x-axis, which we can see here, then if you find the definite integral of this function from a to b, then the value you get will be positive. Okay? But if it's below the x-axis, which we can see here in this next one, if we find the definite integral of this particular function between a and b, it will give you a negative value for that area. Okay? So what that means is that if we're asked to find the area of a curve, or area that's sort of between the x-axis and a curve, and that section is below the x-axis, we need to just, because we're finding an area, a negative area doesn't make sense, right? So we need to make sure it's positive. So there's a couple of ways that we can do it. We can either, by recognizing that it's below the x-axis, put a negative at the front, okay, of the definite integral, which would, when you multiply the negative area by the negative at the front, will make it positive. Or you can put absolute value symbols around the integral, which is to say then whatever that result is, we're making it positive. Or, if you remember from the properties of the definite integrals, if you reverse the terminals, so you swap the positions of a and b, then that will actually change the sign as well. Okay? And we need to make sure we just choose some kind of method to ensure that we're taking into consideration those areas that are below the x-axis, because our area can't be negative. So what happens then if we've got a curve that crosses the x-axis and we're looking to find the area that's bounded by the curve in the x-axis, and we can see that, okay, we're wanting to find the area between a and b, and it's crossing here. If we were to just find the definite integral from a to b of this function, it won't give us the true area. It will work out this value here and subtract that value from it. So it's actually, you won't actually get, you can't just say, work out from a to b and then change it to a positive value if there's more negative area. It'll actually give you a false reading. So what you need to do is work out, well, where does it cross the x-axis? So you need to make sure you know this x-intercept and split it into two integrals. Okay, work out the definite integral from a to c. Okay, and you would have to make sure then that you change that value of the definite integral to a positive value and add it to the definite integral from c to b, so that you are working out those areas separately and then combining them. So that's something you need to make sure of. So if you're asked to find the area, all it's done is given you in words, find the area bounded by the curve and the x-axis from this value to this value. You need to be sure you know whether there are any points where the curve crosses the x-axis, so that you need to then split that accordingly, the integrals. Okay, so for this particular one here, you can see there's a couple of options there, so I'll just make that a little bigger. Okay, So we can see with this as an example, finding the area between the curve and the x-axis between A and B. Okay, we've got this intercept here at C. So, as it's sort of summarised here, if we just found the integral from A to B, it will go A1 minus A2 and give us some value which is not actually the area. So we could do it like this. Okay, the definite integral from C to B of f of x dx, and then if we put minus the integral from A to C, that will correct this because the actual definite integral from A to C will be negative. Okay, and so then putting the negative out the front will mean that it will actually add those two actual areas together. So you will get the true area. Okay, because we've got A1 minus negative A2. Or you could write it like this. Say, right, this is our positive area here, so that's fine. From C to B. And then just go plus and put in the absolute value symbols just to make sure that it's positive. So whatever your value is here, it's made positive, and then we can add them together. Or we know the third way is that this one here has just had those terminals reversed. Okay, those limits changed from A to C to C to A. It's completely up to you as to how you want to approach it. But choose something that you know is going to be easy to remember for you to do. Okay, so we just need to make sure we know where it crosses the x-axis in those situations. Okay, so first example here, express the shaded area as a definite integral, part A. Well, that's all just above the x-axis, so that's nice and straightforward. Okay, so it's just going to be the definite integral from 1 to 4, and so those are our limits. The lower one, the one on the bottom, will be our leftmost value. Okay, so the 1 goes there. And then the 4 is our upper limit. And our function is 1 over x. So then part B, where it says evaluate the definite integral. Okay, we integrate 1 over x, which gives us log base E of x. Okay, notice the absolute value symbols around the x because we need to make sure we can only take logarithms of a positive value. Okay, so that's our integral, and then putting our boundaries then 1 to 4, and then substituting in and getting our value. Okay, because it's asking for the area, okay, then we put in square units. I mean, you could write units with a little 2 above it if you wanted, or write it as square units like that, or SQ units. All that is fine. Okay. Next one there, okay, calculating the shaded area. Okay, so this parabola we can see goes below the x-axis, and so finding the area, finding the definite integral from 1 to 3 would be a negative value. So you can see the way that it's done here in the solutions, it's just put a negative at the front to compensate for that. Okay, so that's fine, or you could just, again, put absolute value symbols around it, or reverse the limits and put the 3 on the bottom and the 1 on the top. And so we can see that as that's worked through, inside the bracket there gives us -7 1/3. So then ensuring that we change it to a positive value to give us the area is important. Okay, so with the next example that's shown there, because this particular one does go above and below the x-axis, firstly making sure you know where the curve crosses the x-axis. Okay, so if you were just given the rule, y equals x cubed minus 4x, you weren't given the graph, but you were told you need to find the area bounded by the curve, and this sometimes it happens this way. The question might be phrased, you can find the area bounded by the curve and the x-axis. And so it gives you no values, no x values or anything like that. Okay, so the question could be phrased like that. Well, in that situation, you would need to know what does the graph look like? Where does it actually intersect the x-axis? And so, well, okay, I can see that it's a cubic, and so that it's a positive cubic, so it is going to be shaped like that. So let's work out where the x-intercepts are. X-intercepts, we're going to let y equal 0, so I'll have x cubed minus 4x equals 0. Factorising, so we've got a common factor of x, we've got x squared minus 4 in brackets, which is a difference of two squares, and so we have x plus 2, x minus 2 equals 0, and so we can see our x-intercepts are 0, -2, and +2. Okay, so that helps us to determine what it's going to be. Right, that must be that point there at -2, that must be at 0, and that must be at 2. So that's the kind of process you need to go through if that's what the question's phrased like. Right, okay, so we can see that the actual curve goes up here further and down further. But when it says here the area bounded by the curve is a boundary to it. Now this is continuing on, it's not really bounded, this is going on infinitely. It's got no end to that area down there. Okay, so it has to be an enclosed area. So that's specifically what we're talking about when it's bounded by the curve and the x-axis. Fully enclosed area. So that then tells us, well, we need to use those limits, -2, 0 and 2, in order to find the area. Okay, so we can see that the left one here is positive, so yeah, just going from -2 to 0 of our function, x cubed minus 4x, and then the way that it's done here, so well, this is a negative area, so we'll just go minus 0 to 2, x cubed plus 4x, minus 4x, and then do the working and solve that. Now, you might kind of ask, well, how much working do I need to show in order to do it? So if we're in a, if it's a non-calculator part, you'll have simple calculations you need to do, okay? And so you'll show basically all that you need to in order to solve the problem. Calculator section's a little bit different because really we could whack this here straight into the calculator. Even, I mean, really what we could do even is graph that, and you can still actually work out what the area is from the graphing part. But what we need to show is with the critical elements, we need to show this part. Okay, we need to show what the actual rule is that we're calculating, so we know what the actual integral is that we need to do in order to calculate the area. You need to do the integration part, so you'll need to get to this bit here, okay, so that you've shown that you can integrate it, but you don't necessarily have to show all of this actual calculation bit. Okay, show your first line, make sure you show your second line, so you're showing that you're integrating it correctly. Perhaps I would suggest probably not a bad idea even to substitute it correctly, but you could probably go straight to the answer after that line. Okay, you could just put that in there so that I mean, the rest of it's just like bread and butter. Okay, yes, you can make an easy mistake when you're putting the calculator, but there's no great skill involved. Okay, you're just ensuring that you know the procedure of integrating and what it is to actually do this next step, substituting correctly, and then you can just get your answer. Okay, so that's the critical working that you need to show. And at the end of the day, you're pushed for time as well in the exam, so you want to be able to write as little as possible to show as much working as you need to. Okay. I mean, it's kind of a shame we've got to sort of teach to an exam, but it's the reality of what we're working with. Okay, so that's what we need to do. In terms of the actual calculator part, you can put in all your limits. You could even do this bit here on your calculator, okay, and to get your answer. So you don't even necessarily have to substitute the part into your calculator in order to get the answer. You could put the integral in and get your answer. Okay. All right. Let's see what we've got here. As another example, sketch the graph of y equals e to the x minus 2, showing all the intercepts and using exact values for all key features, and then find the area between the curve and the x-axis from x equals 0 to x equals 2. Okay, so the working that's done here is just all that's needed in order to find your x-intercept. Okay, so you can see here, first step here, finding the x-intercept by letting y equals 0 and then solving for x, okay, and then finding your y-intercept here as well. So what's it asking? So it's asking to sketch the graph. Okay, so sketching the graph, we've got our key points here, y-intercept, x-intercept, and also this point here corresponding to this x value of 2. Stopping at 2 because we want to find the area between 0 and 2. Okay, so it makes sense to actually put in this value here when x equals 2. So we can see we've got area below and above the x-axis. So you're going to find the definite integral from log base e of 2 to 2. And so that's listed here first in our integral for the area, and then subtracting this negative area from 0 to log of 2. And then working through that problem. So sketching it, okay, however sort of neatly or roughly you need to, depending on whether the question is specifically asking you to sketch it or not. Sketching it is a good idea when you, just in terms of finding and locating where your x-intercepts are. Okay. Any questions about any of that? Okay. All right, so if you're okay with that, then you can make a start on 9F.